by solving the following equations. So we can have equations with logarithms in, okay, and different types of equations they can ask as well. So in this video we're going to look at this sort of type here where you might have a couple of logarithms and then it will equal to like a number, for instance, that we've got here, okay. And the key is just try and get the logarithms together, write them as single logarithms, and then it'll sort of unwrap it for us. So when you look at this here, well, you've got the multiplication law we're going to use here, yeah, because the addition there. But before we can use that, of course, we've got to appreciate there's a 2 here, so we need to take that up using the third law, okay, the power law. Take it up, so then it'll become x squared. So that's the first thing I'll do here. Okay, so I'll go from this line. I won't write by the side here because it's an equation, so I'll work my way down the page. But I'll leave that as it is, log to the base 10 of 4, plus then log to the base 10, well, I'm taking that up as a power, so I've got that there, yeah, equals to then 2. Now remember, the objective is to try and write this as a single logarithm. So I can do that now, can't I? I can use the multiplication law. So it'll be log to the base 10, and I can then, of course, multiply these terms together of 4x squared then, okay? So it's up to you. If you want to, you can put in the bracket if you find that easier to see. You don't have to, okay? But it's equal to then, I've written this as a single logarithm, and of course it's equal to 2 as I've got here. And then we need to go back to our understanding of logarithms. Remember, the logarithm, okay, here we've got a value for it is 2. So, and that value, remember, represents a power, doesn't it? Okay, right? Where the base is 10. So I can sort of get rid of the logarithm here, can't I? I can swing the base, okay, to get rid of the logarithm, rearranging this equation. So I've just got this term here, 4x squared. And if I take that 10 over the other side and swing in that base, it'll be, of course, then 10 to that power 2. All right. And I end up then, of course, having 4x squared then. Well, I know 10 to the power 2, 10 squared is 100. And then it's a simple equation for me to solve. So I'll take that 4 over the other side and divide. So I get x squared is 25. Okay, because 100 divided by 4 is 25. And then, of course, when you square root it, okay, you've got to do plus or minus, haven't you? Yeah. So you get x is equal to 5, or x is equal to minus 5. Okay. However, this x minus 5 is impossible, isn't it? Because when you look here, that won't work, won't it? Because you can't take negative values in the logarithm. Okay. So you could say, look, impossible. Okay. Since log to the base 10 of x here is not defined, right? It's undefined. So the answer here then will be x equals to 5, okay? With the second one here, again, write it as a single logarithm. Now we can go straight for that here now, can't we? Because it's log to the base 3, and when you've taken away, it's the division law, so it's this divided by this, okay? So I would use a bracket here to be clear on that, okay? But it is literally the first term here divided by the second term, that equals to 2. And then, as we've seen before, we can get rid of the log, okay? We can get rid of the logarithm. We can swing that base over, okay, because the logarithm is equal to a power with that base, okay. So if I swing that base over, it gets rid of the logarithm. 3 then to the power 2, and I've got this. So of course I know 3 to the power 2 is 9. And then it's a simple equation work, you know, going back to GCSE, you see you've got this bottom divisor here, take that over and multiply, so maybe create a bracket on that side. Okay. Expand that bracket out. And then it's a case of getting the x's on one side, so take that x over that side, so I get 8x. Okay, when I take that x over and take that minus 45 over, so it becomes plus 45, so it becomes 56. And you can see that x has got to be 7, isn't it? Okay.